Hello and welcome to the next lecture of the cbnst. This is the second lecture in the cbnst series. Basically, this will be our first lecture because in the previous lecture we had only discussed about the syllabus and we'll start our topic study from this lecture. So, my first topic in this series is errors and computer arithmetic. So, today we will talk about errors and computer arithmetic. Error is a very important term into the numerical mathematics. Why? Because we try to find out the error in our computations and we try to minimize that error. So let's understand what is error. Error is basically, so this is the formula of the error. Error is true value of any computation, difference, approximated value of same computation. So any computation, any experiment has two values. One, the true value and the other approximated value. Approximated value is also known as experimented value, which is being calculated using any instrument or any method. So the error basically is the absolute value, or we can say it is the difference in between the true value and the approximated value. For example, let's say we all know what is the value of pi, right? So we will try to find out the error in calculation of the pi. As we know that pi has infinite number of value, but let us consider that the true value of pi till 11 digits after decimal is this. This is 3.14159265359. So if we consider that this is the true value of pi, and let's say someone has calculated the value of pi as 3.14. So now the error will be indicated by the difference between the true value of pi with the calculated value of pi. So now this difference is 0.0015926535559. So this is known as the error in the calculation of the pi, where we have taken this as the true value and this as the approximated value. Excuse me. Now let's talk about the accuracy of numbers. We will see what is the error in detail with more examples in upcoming time. So let's see what we mean by accuracy of numbers. So accuracy of numbers belongs to this computer arithmetic. So we need to study these four things in terms of accuracy of the numbers. One is the exact numbers, the approximate numbers, the significant figures, and rounding of the numbers. So now first is exact numbers. Which numbers are called exact numbers? Let me write some numbers. For example, if I write 1, or if I write 3, or if I write 0.349. So all these numbers will be termed as exact numbers as they have the definite value. 1 will always remain 1, 3 will always remain 3, 0.349 will always remain 0.349. So the values which do not change their behavior or do not change in their value actually are known as exact numbers. Now let's understand what are approximate numbers. Obviously, the numbers which are not exact will be termed as approximate numbers. Let's see the example. If we write 1 upon 3, so if this is 1 divided by 3, as we know that someone could write this as 0.3, someone may write it as 0.33, someone may write it as 0.333, and someone may write it as something else. So we actually do not have the exact value of this 1 upon 3. Hence, this 1 upon 3 number will be termed as approximate value. Let's say another example, we have under root 2. So this under root 2, we also know that it's not having the exact value, so this will be known as the approximate number. So the numbers which are not exact in their value are termed as approximate numbers. Now let's talk about significant digits. So significant figures, let's say from 1 to 9, all the digits are significant digits. 0 may or may not be significant depending upon its position in the number. Let's say, let's understand when 0 is significant and when it is not with the help of these examples and cases. The first case, whenever 0 is in between two significant digits, then it has its significant and this will also be known as a significant digit. So here 0 is significant, as you can see that it is in between two significant digits. So here total number of significant digits will be 3. 1, 2, 3. Coming to the second case, whenever 0 is on the right hand side of significant digits, that means after this 0 we do not have any significant digit. So this will not be a significant digit and this will be called as insignificant digit. So now the total number of significant digits here is 2. Coming down to the third case, whenever 0 is on to the left hand side of significant digits. And as you can see that there is no other significant digits on the left of this 0. In this case also, this 0 will be insignificant. And now the total significant digits come to be 2. Let's discuss the decimal cases, right? In the decimal cases, if the 0 is on the right hand side of the decimal and it is succeeded by some significant digits, that means you can see that this is 3 and 9, then we have a decimal. In that case, these two digits will be termed as significant digits. So now we have 4 significant digits here. Yes, please do not confuse this case with this case, because here we have decimal. In the case of decimal, if we have significant digits previously to the decimal or before these zeros, then these zeros becomes significant, right? So here we have 1, 2, 3, 4 significant digits. So we have 4, right? Now let us consider this next case. Here you can see that these are the zeros after decimal, but we do not have any significant digit on the left hand side. So all these 3 zeros becomes insignificant. So this is insignificant, this is insignificant, and this is also insignificant. So in this case we have only one significant digit. Remember, this would have been significant if there is any significant figure previously, but as in this case we do not have any previous significant figure, so all these zeros will become insignificant. Now let's consider the next case. We can see here, you can see that these zeros are in between these two significant figures, so these also become significant. Now we have total significant digits as 4. In the next case, you can see that this is 3.003. These two zeros are in between these two significant figures. Hence, these two become significant. And this is the 0 which is on the right hand side. But remember, in the decimal case, if it is preceded by any significant figure, you can see that this is 3. So this will also become significant. So we have this case. Remember, we have this case. So this case will be applied, and hence we have all 5 significant digits here. Now let's consider the last case. Here we can see that this is 4 significant digit, and all the zeros preceding to this will be insignificant, and there is no significant digit left on the left hand side, but this 0 will be significant, and this is on the right hand side after decimal, right? So this case will be referred 39.00. So 0 after decimal will be significant if it has a significant digit before it. So this 0 will be significant, this 4 is significant, this is insignificant, and these are all insignificant. So we have 2 significant digits here. In the last case, let's see. This is 0 on the left hand side of a significant digit. So we consider this case. Let's say this will be insignificant. And now these two zeros are in between two significant figures. So we refer this case. So this is significant, this is significant. So we have total 4 significant digits. So by the example, we can understand that when 0 is significant and when it is not. Let me give you a quick revision. 0 will be significant if it is in between 2 significant digits. 1. Second, 0 will be significant if it is after decimal, but there should be 1 significant digit before these zeros, at least 1. So in this case, both the zeros will be significant in the case of decimal. Now this is the second case, this was the second case, and let's say when it is not, whenever it is on the right hand side of a number, let's say this is not decimal. Whenever it is on the left hand side of a number, this is also non-decimal, and 0 will also not be significant in the case of decimal if it is on the left hand side and no significant digit is on the left hand side of these zeros. So all these zeros will be non-significant. Yes, the 0 will be significant on the right hand side after decimal if it is preceded by at least 1 significant digit. So all these rules will be applied. You can note down all these rules and then you will be able to identify that significant digits. To identify significant digits becomes pretty easy. So this is all about significant figures. Now let's discuss about rounding of numbers. So in this rounding of numbers, we have 3 separate cases. Let's say with the examples. Let's say if a number is 3, 4, 5, 7. So we can see that this is a 4-digit number and we need to round it off till 3 digits. So let's say the nth digit, in this case 3, 4, 5, 7, we'll say nth digit is this and this will be n plus 1th digit. Now let us discuss case number 1. So case number 1, if n plus 1th digit is greater than 5. As in our case, we can see this is n plus 1th digit, this is 7, this is greater than 5. And what we used to do, we simply eliminate this nth plus 1th digit and we increment 1 into the nth digit. So now this will become, let's say 3, 4 and we'll increment this nth digit. So this is 3, 4, 6 and we'll eliminate this 7th digit. So this will become 3, 4, 6. Okay, so this was the first case. Now the second case, if n plus 1th digit is less than 5. So let's consider another case. Let's say if it is 3, 4, 5, 3. So here this is the nth digit and this is the n plus 1th digit. So now if n plus 1th digit is less than 5, as in this case you can see 3, this is less than 5. In that case what we will be doing is, we will simply eliminate this digit and we will not do anything to the nth digit, that will remain as it is. So the result will be 3, 4, 5. Right? Why this? Because we simply eliminate n plus 1th digit and rest we will keep as it is. So this is the second case. Now let's discuss the third case. The third case, whenever if n plus 1th digit is equal to 5. So this is the third case. So what will be the third case? Let's say if it is 3, 4, 3, 5. So we can see here nth digit is 3 and n plus 1th digit is 5, and this is the third case that n plus 1th digit is equal to 5. Then what we have to do? This has 2 subparts. Let's say part number A. If n is odd, and part number B, basically if it is nth digit, if nth digit is odd, and the sub part is if nth digit is even. So we have 2 sub cases. Whenever n plus 1th digit is 5, right? So let's say in this case n plus 1 digit is 5, then what we'll need to do is we will look at the nth digit also, and depending upon the nth digit, if nth digit is odd or even, we'll perform action. So let's say what is the action first? If nth digit is odd, So what we'll do, if nth digit is odd, we'll simply eliminate n plus 1th digit and we will increment nth digit by 1. When this will happen? When nth digit is odd. So this will become, let me write this answer, 3, 4, 4. Why? Because n plus 1th digit is equal to 5. Then we look at nth digit. This nth digit is odd. So we will increment this nth digit. So this will become 3, 4, 4. And the second sub part, let us discuss another example for the second sub part. Let's talk this example. Let's say 3, 4, 4, 5. You can see in this n plus n digit is equal to 5. Yes, it is equal to 5. And nth digit is even here. So if nth digit is even, what we do? We eliminate n plus 1th digit and we leave rest as it is. So now this is 3, 4, 4. So this is the rounding off. So these are the three most basic cases of rounding off. Let's revise, have a quick revision. If n plus 1th digit is greater than 5, then we eliminate the digit and we increment nth digit by 1. Second, if n plus 1th digit is less than 5, then we eliminate the n plus 1th digit and we'll keep rest as it is. Third case, if n plus 1th digit is 5, then we have two sub cases based on nth digit. If nth digit is odd, then what we used to do, we eliminate n plus 1th digit and we increment nth digit by 1. So now this will become 3, 4, 4. And if nth digit is even, then what we do, we eliminate n plus 1th digit and we keep rest as it is. So this will become 3, 4, 4. So I hope you have understood all these concepts which we have talked today. That is based on accuracy of numbers, exact numbers, what are exact numbers, approximate number, significant figures, and rounding off numbers. So that's it for the today's lecture. In the next lecture, we will discuss about more. We will discuss more about errors. We will discuss about sources of errors and we will discuss about types of errors. Thank you.